Okay, dann fangen wir auch schon an. Ich spreche heute über Access Control in the Enterprise in Kubernetes. I think I'm going to switch to English. Is that what the hand was for? Sorry about that, yeah. Just because I'm in my hometown. So today my topic is Kubernetes Access Control. I'm going to start by introducing myself. My name is Bruder. I'm part of the field engineering team at Rancher Labs. You can find me on GitHub and ping me on my email address. Let me give you a short introduction in the company I work at. So Rancher Labs is a US-based company. It was founded in 2014. We currently have around 140 employees. Basically we build software to make it easier to adopt containers in organizations. We've been building this kind of software since almost 4 or 5 years now. Initially, we supported a lot of different container orchestrators like Docker Swarm, Mesosphere, Kubernetes. And around 2017, we basically made a full switch and went full on Kubernetes. And today, we have around 20,000 installations of Rancher around the world that people use to manage their Kubernetes clusters. All of our software is completely open source. And besides Rancher and Rancher OS, we actually have a lot of other projects that we are currently working on, including Kubernetes for the Edge, K3S, and a cluster networking, multi-cluster networking solution. So you can find all these projects on GitHub if you're interested in those. So let's look at what Kubernetes Access Control is about. So basically it involves two processes which are between a user request and a resource in Kubernetes. And the two processes that we are focusing on today are the authentication and the authorization. There's kind of a third process in Kubernetes, but we're not going to talk about that today. So admission controllers, basically, they give you another level of controlling requests based on their content. Like, for example, pod security policies in Kubernetes, they use the admission controller mechanism. So let's first get just a basic understanding. Obviously, this is probably most of you know what the difference is between authentication and authorization. So we can say authentication is basically about establishing the identity of a user by validating a factor, an authentication factor that he presented, like a password. And the authorization on the other part is once we already have authenticated a user, we want to establish whether a particular user request to access a particular resource should be allowed for that user. So that's the basic difference between the two. And when we talk about authentication mechanisms in Kubernetes, it's important to point out that Kubernetes itself doesn't see itself as a pass. So the Kubernetes developers really want to focus on orchestration of application and distributed environments. So some of the typical integrations that you will find in a pass system, maybe like integration with LDAP or Active Directory for authentication, they do not exist in Kubernetes. And the Kubernetes itself also does not have a user management. So if you look in the Kubernetes API, there is no actual user resource. So what then are the integrations that Kubernetes offers? So these are basically the native authentication mechanisms for Kubernetes. So the first two, I would say, are not interesting at all, just because it's basically the first one is HTTP basic auth with a static password file, and the second one is using a Bearer token, basically a token that you put in the HTTP header, which also uses a static token file. So not really interesting, especially if you are talking about enterprise. So the next interesting one is actually client certificate authentication, and we're gonna look at this a little bit more. And also OpenID Connect is a very interesting one. There's also two other ones that are less used. So there's webhook authentication. Basically, what that means is when the user adds a token in his request, Kubernetes will not validate the token itself, but it will invoke a third party to authenticate the token. So this could be an external service, maybe some really custom thing that you have implemented. And then finally, there's an auth proxy. So you would use that mechanism if you have an authentication proxy in front of the Kubernetes API that basically does the job of authenticating the user, and then would pass on some information about the user identity also in the HTTP headers. So looking at client certificates, how does that work? So basically it works by Kubernetes verifying the certificate chain of the certificate that the client presented to it. So there's a handshake happening, and then basically each Kubernetes cluster is configured with a CA for a client certificate that it trusts. And when a client presents that a certificate that was signed or where the chain can be traced back to the root CA, it is authenticated by Kubernetes. With a certificate, you can actually also provide user attributes. So you have a username in the subject field, and then you can even include group membership information in the organizational unit field. It's a very secure authentication mechanism for sure. There's some disadvantages. First of all, client certificates for human user authentication is not something that is widely used in enterprise or in many organizations. The second thing is you have a certain management overhead. For example, you need to manage certificate expiration. But most importantly, I think the most important drawback of client certificates is actually that Kubernetes does not support certificate revocation. So it's basically once a user, always a user. What happens when there's an offboarding? Someone leaves a team and you should be removed from the cluster. It's not actually possible. So you can help yourself somehow by basically removing any RBAC policies for that user, but that doesn't change the fact that he will still be authenticated and will be a valid user from the perspective of Kubernetes. So moving on, OpenID Connect. What is OpenID Connect? It's an authentication mechanism built on top of OAuth 2. It basically defines a sign-in flow where an application can authenticate a user using a third system, and it can obtain some information about that user, such as the username and the group membership. The user information is encoded in a JSON Web Token. It's specifically called ID token that includes the claim information about the user. And if you look at the flow of the OpenID Connect very quickly, basically you see the components that are involved here. Basically, a user, you have an identity provider, and keeps it in the API server. So what first happens is the user logs in the identity provider. He obtains the ID token. And then every time he performs a request for the Kubernetes API server, the API server validates the signature of the JavaScript token, so JSON token, sorry. And that signature, so basically, is validated against a known CA, a known root certificate. So there are some prerequisites, of course, for OpenID Connect. The most important being you need an IAM service that has that provides an OpenID Connect service, so-called identity provider service. So some examples of IAM services, solutions that support that. Ping, Federate, Okta, Dex, Geeklog, Google IAM. If you have ever used social logins on the internet, it's also OpenID Connect, basically. This is a great way to set up authentication with Kubernetes, unless you don't have these services, because then basically you need to integrate a new authentication mechanism just for the purposes of doing authentication in Kubernetes, which basically then increases your Kubernetes administrative complexity. And also some organizations, it will just not be acceptable that you basically create a new authentication or implement a new authentication mechanisms. A lot of organizations basically tell you that every application needs to authenticate users directly with the central enterprise user directory. So there's another option that we have actually implemented in Rancher. So because Rancher is multi-cluster management, we basically had the idea of doing a global central authentication proxy. So that means that any request to any of the clusters that Rancher manages are authenticated at the same network endpoint. And it also allows basically users, even when they want to access a cluster in the cloud and a public cloud, to use the enterprise identity and the enterprise credentials to authenticate in the cluster. So basically this is how it looks in Rancher. It's actually pretty simple. What you need to know about Rancher is that we use the Kubernetes API as our data backend. So we create custom resources that represent users, groups, and other things, and that helps us then to perform the proxying of authentication. So what happens is the user sends a normal Kubernetes REST HTTP request to the auth proxy, and then there's a token that the user includes, a bearer token, and then Rancher validates the token. It does a lookup so that we know to which user the token belongs, any groups the user might be a member of, and then we also derive the cluster that the user wants to talk to based on the URI path. And then basically the request is forwarded to the cluster itself, and we just add two headers to it, which is something that Kubernetes supports for user impersonation. So we basically add the user and the group info there, and then the actual authorization of the request happens on Kubernetes. Rancher isn't involved in that at all. So that's kind of how we do it. The advantage, of course, is for once you only have to maintain one integration with your external identity provider or IAM system with Rancher. You don't need to set it up for every cluster that you have. And also you can give your users a single endpoint regardless of the cluster they want to talk. So even if the cluster is maybe running somewhere in the cloud, you don't even need to give your users access to the master kube API server. You only have to give them access to the Rancher auth proxy endpoint. Okay, so that's the authentication part. So we know now who the user is. We know the user's identity. We know maybe any groups that he belongs to. So now to the authorization part. And traditionally, so historically, RBAC was the authorization mechanism in Kubernetes. It was basically a file-based, attributes-based control using a static file. So every time you needed to do changes, you needed to restart the Kubernetes API server. Since I think Kubernetes 1.9, RBAC is the default, so role-based access control mechanism. And there's still another one, webhook authorization. So it's a little bit similar to the authentication via webhook. It basically allows you to do some custom, authorization logic. So basically, webhook authorization means every request that comes into the Kubernetes API server is forwarded to an external service, via REST query, and then you can inspect that external service inspects the request and can then basically reply with a accept or deny. So, quick definition of RBAC. Role-based access control is basically a method of access control where the user's role, so where access is granted based on the user's role or the job in an organization. And the principle, the main security principle is that of the least privilege. So basically that a user should only have the permissions in the system that he needs to perform his duty and nothing above that. And next question, where do we actually apply RBAC? So you have to know that Kubernetes is an API-driven system. So all the resources in a cluster, they are actually represented by an API object. So even something like nodes, they are represented by API objects. And even things like opening a shell into a pod or streaming logs from a container, it's all done via an API endpoint. So that's great. So we just have one point where we do have to do this authorization. That is definitely making things easier. And the other thing is, what is interesting to know about Kubernetes is the kind of, the API structure. So Kubernetes API has a lot of resources. That's just comes from kind of the design of Kubernetes. It has a high level of abstraction. So that results in a lot of different API resources. Like you have a pod, you have a volume, you have a configuration for the pod, you have secrets and so on. So this means there's a lot of granularity, which is great for RBAC because you can really, you can really configure fine-grained access control. You can say this user role just allows someone to update secrets, and the other user role is just there for upgrading an application, but not seeing the actual secret configuration. So one reason for this kind of API is that it's not a user-facing. It's not an API that was created for a user in the first hand, but actually the Kubernetes API is used by all the components running in the cluster. It's the main means of how services that are part of Kubernetes communicate with each other. Yeah, so as I said before, this kind of granularity is both great because you can really pinpoint and you can really apply the principle of least privilege in your rules, but it also makes it a bit more difficult because if you really want to properly configure RBAC, you need to kind of know all these API resources and how they relate to specific user tasks. So which API resources are, for example, involved if a user wants to exec into a pod. So you need all that knowledge to properly work with it. And because that's kind of like a steep learning curve, it's not straightforward. A lot of people actually just want to make their life easy and basically use cluster admin role for everything. So cluster admin is one of the 3 or 4 built-in user roles that exist, and it's basically the equivalent of a super user on a Linux OS. So that's definitely something one should avoid. So this is an example. So this is basically how you the rule to allow opening a shell to a pod. You need to know that this is actually done with a sub-resource. So pods exec sub-resource, and the HTTP verb is create. Yeah. So RBAC is critical for the stability and for the security. That's kind of obvious, but let's just look at why this is so important. So first of all, user mistakes. So by doing fine-grained RBAC, you can kind of limit the effects of a user mistake. Like for example, this user here deleting a namespace that you didn't know was important. It also limits the effects of compromised credentials. So in the case before, if you only use cluster admin for everything, then once the credentials for a cluster admin get compromised, basically the attacker has full access to the cluster. And it's also important for any external systems. So users integrate Kubernetes with CI systems or other external services. So it's also important that you apply the principle of least privilege for these integrations. So how do you start with RBAC? I mean, besides getting familiar with all the API resources, it's kind of identifying the landscape of your clusters in terms of clusters itself, but also namespaces. So how many clusters do you intend to manage? How do you kind of scope clusters? Like, for example, are you creating clusters for specific deployment stages? Or are you creating dedicated clusters for specific teams or business units? And then, of course, also, what are the typical roles of users in your clusters? And are there any maybe organizational policies that you need to implement in the cluster, like access policies? So there might be specific policies for accessing a service that has direct access to a database for specific data or some things like that. And talking about namespaces, so what are actually namespaces? They're basically a logical construct that allows you to isolate resources in a cluster. And in other words, namespaces are also a way to do multi-tenancy in a cluster, because they usually provide the scope at which you configure access and also at which you configure network policies. So you can use namespaces to basically share resources in a cluster between different teams, or you can also isolate different applications running in the same cluster. Again, for namespaces, you need to just kind of come up with your namespace strategy. So what is the scope that you do on the namespace level? Are you using namespaces to separate teams? Are you using namespaces to separate deployment stages? So this would be like the most simple example. You have a single cluster, and then you use namespaces to isolate your deployment stages. So this is, I think, perfectly suitable for smaller organizations. There might be some. I mean, it always depends on your requirements. You might have some strict requirements to not share physical resources between prod and pre-prod, but again, this can be different from depending on where you are. The next one would be that you're maybe like a little bit bigger organizations, and you have different teams that you kind of want to give their own resources in a cluster. So you could basically still work in a single cluster, but you can have multiple namespaces per team, and then each team can again separate the different deployment stages for them. And so this is more like I would say like maybe a more common scenario. So here you have actually a physical separation of deployment stages. So you would have a dedicated cluster for dev and test, and then in that cluster you can put you can separate different teams with namespaces. And then you would have maybe another cluster for stage and for prod. So this is basically, it provides better security because the isolation between prod and pre-prod is harder, because it's not just kernel namespacing, it's actual physical hardware, or at least a separate virtualized hardware. It might also be necessary to to prevent access to any external service in a specific subnet. So maybe you have a production database that is that you need to access from the cluster, and in order to only allow prod workloads to access that, you need to move all that other stuff to a different cluster, running in a different subnet with different firewall rules. So and then you can even get more complex, basically. So instead of giving each of your customers or teams a single namespace, you can allow them to create indefinite namespaces. Because namespaces are also, they're also good for kind of organizing bigger, application stacks, maybe some big microservices stacks with a lot of services, and you kind of can give them a more logical organization. And then the next thing is basically to identify user roles. So you start by the actual user role. What is the job of the different people that work with your clusters? Do you have dedicated application operators, or are you more like do you have more like a DevOps approach where developers also take care of putting new versions into production? So based on that, you then create corresponding Kubernetes roles that define a specific job role. And then you kind of need to map those in the clusters. So, and different user groups may have different roles in different clusters. So, for example, you might allow developer, you might give them a lot of rights, a lot of permissions in the dev cluster, because you want them to be able to be agile. But on the other hand, in the production cluster, you probably want to, if you want to give them access, or maybe you just want to give them read-only access, or the ability to inspect logs of containers or something like that. So you can see already this one group or this one person or group of person already may have requires different policies in different clusters. Yeah, so how do you do RBAC anyways in Kubernetes? So this is just a short primer. So basically, how do you configure RBAC? The RBAC in Kubernetes consists of basically three elements. One is a subject, so the person or the process that wants to do an operation in the cluster. In Kubernetes, it can be three types of subjects. So there can be a user, it can be a group, or it can be a service account. Service account are usually used for processes, both internally or externally of the cluster. And then the second element is the role. So a role specifies basically the permissions that are granted for a specific resource. And a role is basically a combination of an API group, a specific resource in the API group, for example, a pod, and a verb. So the verb defines basically the CRUD privilege, create, read, update, delete, and then also some additional verbs in Kubernetes that are specific for Kubernetes, like, for example, watch, to listen to events to that resource. And then the final piece that puts these both together is the role binding. That's basically where a subject is mapped to a role in a specific namespace or in the whole cluster. Yeah, so I mentioned already there are some built-in roles in Kubernetes. So I mentioned the cluster admin. This role basically gives you full rights in the whole cluster to all resources. And then you have three roles that you usually use to grant roles in a namespace. So basically the admin has basically full access to resources within that namespace that it's granted in. He can also basically add new users to the namespace. And then the edit role has also access to most of the resources in the cluster, but can't change basically the membership of the namespace. And then there's a read-only role. So these are quite helpful. At the end of the day, you're probably going to end up creating kind of your own roles, so that you match your organizational policies. And so that's kind of a graphical representation of how you create an RBAC policy. So you have a subject on the left side, and you have the role on the right side. So a role has a scope, and that is either a namespace or a cluster. So you can create a role that is only valid within a specific cluster, and you can also create a role that is valid for the whole cluster, which is called a cluster role then. And the difference is basically you need to know that in Kubernetes there are namespaced and non-namespaced resources. So there are some resources that cannot be mapped to a specific namespace, like for example nodes. These are cluster resources typically, or volumes. They are also typically cluster resources. And then you have other resources that are namespaced, so they can exist within the scope of a namespace, like secrets and pods and so on. And another thing, if you haven't used Kubernetes at all, is basically what you see here. So this is a typical description. This is a typical configuration file for Kubernetes. It describes basically an API object that should be created. And so this is basically how you do any configuration in Kubernetes. It's all via the so-called manifest, which is a JSON or YAML file, again describing an API object. So you have API type as a kind, you have an API version, and then you have all the metadata, and then you have some specific fields that are specific for the type. So in this case, we have a role, so we have a list of rules. And the role basically is then constructed with 3 keys. So there's an API group. Kubernetes has different API groups. There's a core group, which has like stuff like pods and stuff like that in it. And then you have for example, deployments there either in the extension or apps group, depending on the Kubernetes version. So you see, it's not that straightforward. But I mean, it's actually straightforward, but you have to know all these API details. And then you have the resource is it can be a deployment, a pod replica set. It's what the user is working on, and then the verb determines what the user can do, like get, list, create, or delete. And then on the right side we have the role binding. So in this case we want to assign a role to a user, and this user is called superdev, and the role that we are assigning is listed in the role ref. And you can see that it's referenced by name. And one interesting thing also is that you can actually create a role binding that references a role that doesn't exist yet. So this is also can be a little bit dangerous sometimes. Because it's just by name, so anyone could create then the missing role with a lot of privileges, and then the user would gain that role. So that's also interesting to know. So you know now how to create basically RBAC. And it's nice for, if you have a little cluster with maybe a handful of users, it's perfectly doable to manage the RBAC using these configuration files. But the job gets a little bit more difficult if you have more users, a lot of clusters, a lot of namespaces. There are some requirements. For example, security ops, they want to do an audit, and they want to easily see who currently has access to what resources. So how do you provide that? Another one is basically the consistency. So you may have a central repository, like maybe a Git repo, where you have captured all these roles and role bindings, but what guarantee do you have that your clusters are actually configured in the same way? So the more users, namespaces, and clusters you basically have, the more you will find yourselves in a sea of YAML files. And besides the difficulty of knowing if the cluster state matches those files, it's also kind of like difficult what these files actually tell, what kind of permissions these files actually configure, or what policies they configure. So there's some best practices that you can use if you do this kind of manual RBAC management. So one is you can enforce a naming scheme for your files, so that actually you don't need to look at the content and you know what these policies do. Right, so you can do something like a user can, and then the task that this role grants the user. Another best practice is actually to not use any roles, but to use global cluster roles at all. And then in every namespace that you configure, you reference the cluster role. That way, you just have to manage one set of roles in the cluster, and you don't have to manage roles for every namespace in the cluster. And the next step you can do is you can create some kind of automation to apply RBAC changes. So if you already have that, if you already have these RBAC configurations in a Git repository, you could then build some, some automation, some script, maybe with a CI pipeline that automates the application of the changes in the cluster, which is only easy on the first view, but it's actually not that easy. So you could think of just doing something like kubectl apply. So this is a update or create kind of command. So you could just do that, kubectl apply for the whole directory or something, every time something changes. But the problem is, this works great for any roles that changed or are new, but it doesn't work if you delete a role here. So it doesn't work for revoking access or removing roles. For that, you actually need more advanced, a more advanced algorithm. Like you need to do an actual diff between the cluster state and the GitHub. And of course, the number of files will still increase every time you get a new cluster or you create a new namespace. You will have more files. And another thing is maybe basically now namespace, because you have this central repository. Namespaces now become kind of a resource that the Kubernetes admin manages. So maybe every time a team wants to have a new namespace because maybe they have a new component in their microservice which they want to run in a new namespace, now basically they have to write a ticket to Core IT to provisioning a new namespace. Yeah, so we saw this in Rancher as well. We have been supporting Kubernetes since 2015, I guess. This kind of challenge with RBAC management, and we kind of thought about how we could do that, how we could automate that in the Rancher software. And we actually thought about, actually, if you look at the Rancher software architecture, it's a really native Kubernetes application. So we use a lot of the patterns that Kubernetes itself uses to manage your containers and stuff. And one of them is the control pattern. So this is kind of a central property of the Kubernetes architecture, is the use of controllers that have a very specific purpose. So let's just look at the control pattern really quick. So this is used by for a lot of automation in Kubernetes, like for example, making sure that a certain number of pods are running, monitoring your nodes and all that stuff. All this is often done with a control pattern. And the control loop in Kubernetes is basically a software loop that watches the state of the cluster by querying the API, compares it then to the current state, and when there's any difference between it, it tries to drive the actual state to the configured state, which is called reconciliation. For example, again, an example would be the replica set controller. So you have a replica set describes basically how many pods should run of a specific pod and describes the attributes of the pod. And the replica set controller watches all the time watches the configured state. Like for example, I want 5 instances of this pod, and then it looks how many pods are actually running. And if there are not 5 running, it tries to drive the state towards 5 running. So in this kind of pattern, we actually using that in Rancher to manage RBAC, but on a global scale. So our controller uses the RBAC rules or the RBAC policies that the user has defined in Rancher, and then compares it with the state of all clusters that Rancher manages. So by that, basically, now you have software that gives you the guarantee to have a consistent configuration in the cluster. And you also have software taking care of any erroneous configuration or any orphaned or revoked RBAC rules that may still be in a cluster. And and then of course you have basically a very good visibility also in your rules, because you just have a single source of truth where your policies are configured. And the second kind of approach that we did to manage this is making use of Kubernetes custom API resources. So this is kind of the way how you can extend the Kubernetes API for your own purposes. So basically, it allows you to create new types in the Kubernetes API. And we use this heavily in Rancher. So Rancher actually doesn't use a data backend like a MySQL or something database. We actually store all our configuration. We store all our state in the Kubernetes API. And by that, it means we are storing it in etcd, in the key value store of Kubernetes. And to manage the RBAC, we actually make use of that as well. So if you look at this diagram, you see there's something called Rancher Manager Cluster. So this is a Kubernetes cluster which is dedicated for running basically the Rancher server. And you can see that we are relying on a couple of custom resource definitions to manage RBAC. So first of all, I mean, we have basically the roles. So these are the central roles. And then we have bindings that basically define a mapping between users, groups, and a role in a specific cluster. And then, so as an administrator, I just define this centrally, and then I have basically software, what you can see, like namespace controller. And these other controllers, they're basically doing their control loop, and they're ensuring that everything is in sync with the central state. And then we can also see that we actually have also user group objects, which are a representation of users and groups that are managed in your IAM externally. And again, we have some kind of controller that syncs the user and groups from that external directory. Yeah, so let's maybe jump in a very quick demo. So I have here a demo instance of Rancher. I think my Wi-Fi is not connected, so let me just do that. Okay, so I have a demo install here with a single cluster running in DigitalOcean right now. I think it's running in Frankfurt. So let's just, for the demo purposes, really quickly create a new cluster here. Oh, sorry. That's always biting me, the PowerPoint stuff here. Okay, all right. So once again, I have already a cluster running here. Now I'm going to add a second one. So this is running in Frankfurt, I think. I'm just creating a second one really quickly. So I'm assigning some roles, some node roles. So I need at least a worker, and I'm going to create another master here. One master, 2 workers should be fine. And okay, so what? Oh, no template is required. Okay, so I'm going to take this one here. So this will now provision the virtual machines in the cloud that I want for my clusters. Basically, one to run for the master, and it will give me 2 worker nodes. It will install Kubernetes 1.13. It will do. It will use Kernel as an overlay network, and yeah, that's basically it. So while this is provisioning, let's look at the roles that I talked about. So basically, you can see in Rancher we have basically 3 levels. So we have a global level, we have a cluster level, and then we have a project level. So everything that is centrally configured is on the global level. Like for example, this is where I have currently set up my authentication with Active Directory. Yeah, so pretty straightforward. And note that I have only have to do this once on the global level, and any cluster will automatically basically gain the ability to authenticate users using that. And then the other thing that I have globally is my roles. So I've created there's a couple of built-in ones. I've created a custom one here. So I've created, because we had the example of the exec pods before. So I have one here. Basically, this should only allow you to list and inspect pod resources, and also query pod logs, but nothing else. And then I have created another custom role. You can see that, because that's also quite nice in Kubernetes, so roles can be additive. So in this one, I'm inheriting the permissions to view pods and logs, but I'm adding the example before that I had. I want this user to also be able to open a shell in a pod. So I put pods exec create. And now basically what I can do is I can start by authorizing a user here. So I'm going in the dev cluster here. I'm looking at the members list here. Actually, I'm going straight to the project, default project, members. And now I'm going to add a user. And you can see I'm getting the lookup from the LDAP or from the Active Directory. So I'm going to add test user 2. And I'm going to give him permissions to exec pods in creating that user. And then let me just log in as that user. You can see I'm only seeing the one cluster, and I'm only seeing the project in which I'm authorized. And now, because I want to work with the kubectl, I'm using this kubectl that Rancher generates for my account. This is a specific token mapped to my account. And I will use that to set up my config. Oops. Okay. Just see what's the name again. So now I'm gonna just override, because I have another Kubernetes config. Just override it with the one here. And what did you want to do? Get pods. So you can see, I can see the one pod that is running, Nginx pod. And I should also be able to exec into the pod. Yeah. So now I'm in the pod. So that worked. It allowed me to do it. And now let's look back to the cluster. We're not quite in there yet. Let's see what's going on. So we have already the master API is already running, and it's still working on the worker prods. Let's see. Maybe I can already configure the members though. So this time I'm going to add again the test user 2, but because this is the prod cluster, I don't want him to. Don't want to allow him to exec into pods. So, oops, sorry. Actually, I have to go to the project. Test user 2, so now the role without the exec. Okay, there it is. And now I'm logged in here as the test user 2. Now I can see the other cluster. Oh, this cluster, okay, maybe it's not yet fully there. Okay, so it's still setting up the worker node. While it's doing that, actually let's create a pod, because I think we don't have a pod here. So I'm just going to deploy, again, in this cluster, the Nginx image, like I did in the other one. We have already a worker, so it should start on one of the workers. And now let's go back here. Demo prod. So now we're in the demo prod. Now we're going to get the kubeconfig file for the prod cluster. And configure that here. And now we can run the same command. Oops. I don't know what's going on here. Oh. Okay, sorry. Of course, we have to use. So here's the Nginx pod. Of course, it has a different ID. And now it's trying to exec. And you can see that it has denied our exec because we have a different role in the prod cluster. And if you go back to the demo prod, actually, now it has fully set up the nodes. And if you go back to using my admin credentials, I can actually list the cluster roles. And what we actually do in Rancher also is we use kind of sort of unique IDs for the cluster roles. To kind of make a more harder mapping between the roles and the user instead of just using names. Yeah. Oh, okay. No. So the source control was basically how you would do it without any additional tool. So basically like when you manually manage Kubernetes. With Rancher, all the roles are maintained in Rancher itself. So Rancher, instead of the repository, Rancher becomes the central source of truth. Right? Yeah, okay. So I think we're pretty good with the time. So there's 6 minutes left. Let's just, before maybe some questions, let's just point out, so I talked about our software, it's all open source, it's available on GitHub. We don't have any, like freemium stuff going on, so you get all the features that, any of our enterprise customers would also get with Rancher. It's pretty easy to get started, so the server the demo install that you saw is actually just running from a single Docker container. Of course, for production installation, it's a little bit more you have to do. But yeah, so if you want to try it out, you can start the whole thing on your laptop. And if you want to get in touch, with the community or so, the best way is to join our Slack channel. So there's always like a couple of hundred users online. This is a great source of any, for conversation, or if you have any questions while you're using Rancher, you can get some free advice there too. And with that, we have a couple of minutes left, and maybe I can answer some questions if there are any. Yeah. There's an audit log for everything that you do in the Rancher GUI. So not the Rancher GUI, I should say, in the Rancher API. So because actually the GUI, what you see is just another API client. So I mean the powerful things, like all the features, all the automation that Rancher does, is available via the API, and you can actually see for every object in the GUI, you can have a look at the REST representation, REST object of that, and you can see exactly how to interact on the API level. And so everything I do in the GUI is an API action, and it's all recorded in an audit log. Yeah. Is there any more questions? Yeah. Yeah, so it's good that you ask. We have actually finally released the Rancher 2 provider for Terraform. So what that allows you basically is to declare all your clusters and projects as code. So basically the provider integrates with a running Rancher instance, and you can define in Terraform the whole cluster, like starting from any virtual machines or any compute resources that you create, and the cluster, like the whole cluster parameters, like the Kubernetes version, all of any of the hundreds of Kubernetes options, members, and stuff like that. So really the whole thing that you would do in the GUI, you can do that with Terraform too. I think roles are not yet supported, but I'll have to double check about that. That's definitely something that we work on it. It's also worth mentioning that the Terraform provider is also community managed now. We basically have given it to the community, so any kind of contributions are welcome. Yeah. That's correct. I'm not sure we really support that, like on a SLA level or something like that. The best way, how I would do it, I would basically snapshot the whole etcd database. I mean that's true for most Kubernetes stuff. I mean, exporting the whole cluster as YAMLs, as YAML files, I wouldn't recommend that. But if you do a snapshot of etcd, you could use that to stand up a new cluster somewhere else. That's what I would do. But in the end of the day, you're right. Basically everything is a custom resource. So you can. Okay, so in that case, I'm not actually having access to the cluster. But if you set up Rancher in a Kubernetes cluster, you can actually, if you do like a kubectl get CRD or something, you will see all the custom resources that Rancher uses. Like you will see users, objects, and stuff like that. So that is basically the state. That is the only state of Rancher. So no more questions. Then thank you very much.